Welcome to another video by Geosystems. Today I want to show you how you can atmospherically correct satellite images by using the ATCOR Workflow for Imagine dialog. Maybe you have already seen the other movie, How to Use the ATCOR for Imagine Workflow with the ERDAS IMAGINE Spatial Modeler. In this example, a Sentinel-2 multispectral image of San Francisco will at first be dehazed and thereafter atmospherically corrected with Addcore2. Additionally, a haze map with different classes will be created. Oh, by the way, this satellite data has been simply downloaded by using the Sentinel-made simple downloader of Geosystems. A short info how the Sentinel data is organized. Here in my folder, you can see the SAFE directory. SAFE is the ESA-specific format for their data. Today I'm interested in a granule 10 SEG, which shows the area of San Francisco. Generally, Sentinel-2 satellite images are provided as JPEG 2000 files with one file for each band. In this folder you find the granules in which the JPEG 2000 images are stored. Okay, let's get this on. I create two folders which I name ATCOR Project and ATCOR_output. First of all, I want to show you the scene we are going to atmospherically correct. We can see that there is a lot of haze in the image. Here it makes sense to previously, in a first step, use the Addcore Dehaze. For dehazing the scene, I navigate to the tab Toolbox, go to ATCOR Workflow for Imagine and open the drop-down menu. There I select Run Addcore Dehaze. A graphical user interface opens. First the tab Project. For the operation mode, select Create ATCOR Project. In the input box, select the already created project folder. For the sensor, pick the Sentinel-2 13 bands. And for the image file, I select Metadata file in the XML format. Thus, I move to the granule folder and select my 10 SEG granule. There is the XML metadata file, which is Sentinel specific. In the output box, for the dehazed image, I select the already created output folder and specify the name of the dehazed image, beginning with the acquisition date, which is 2015-11-17, and define the ending with _dehaze to make it clearer for further processing. Now, second, the tab Settings. In the sensor information, nothing has to be set, as it will be directly imported from the XML metadata file. The same is true for the geometry box. For the dehazing parameters, I change for the dehaze method to standard. For the dehaze area, I keep land water pixels. I check to use the cirrus band, which is band 10 for Sentinel-2. And I keep the default for the interpolation method with bilinear fast. Now I am ready to run the process for dehazing the scene. An Edward window pops up as we are in the free license mode of IDL. Just click on it. At this point the process starts and might take about 5 minutes to finish the dehazing. In the meanwhile, some info what ATCOR is doing. While an ATCOR project based on a Sentinel-2 dataset is created, the following tasks are executed. It reads out the information from the metadata file, which comes in the XML format. It compiles a layer stack, either with 13 bands at 20 megapixel size or with 4 bands at 10 megapixel size. This depends on the sensor you specify. In this case, the 13 bands on 20 meters. Important to mention at this point, the created project can be used for all three ATCOR processes: dehazing, Addcore2, and Addcore3. This is done. Now I want to show you the result of the ATCOR dehaze. First, I go to the project folder. There I find a created folder named TOA Reflectance. Here is the layer stack which the program created from the original bands. I fit the layer to the window size and quickly have a look into the image metadata. You can see this is a layer stack of 13 bands with a spatial resolution of 20 meters. I take this original image to compare it now with the result of the dehaze process. Thus, secondly, I go to the output folder and select the dehazed image. You might already see a strong change. Let's compare. Therefore, I switch the swipe tool on. Have a look on the difference by yourself. I close the transition to load the haze map by dragging it into Imagine. Well, I will use the swipe tool once again. I want you to focus on this nice haze South San Francisco indicated with the arrow. We see that the ATCOR Workflow calculated a map with different categories. Let's have a look into the attribute table. Here in blue is the class over water. ATCOR detected clearly haze. The haze map category changes over land, and overall the haze is easily detectable with the eye. Now let's examine the project folder for a second. There are a number of different files. In the TOA reflectance folder, there is a layer stack of the original image with the band, order and pixel size as it is required by ATCOR Workflow. One folder higher, Geosystems ATCOR project file. This ATCOR project text file contains some basic info on the project. Never do rename this file, otherwise the ATCOR project is destroyed. With cal, we do get the calibration file, and the log file provides some detailed information about the executed process. So our scene is prepared and dehazed. Now I can go on with the next process. Again, I do go to the ATCOR Workflow for Imagine tab. This time from the drop-down I select Addcore2. First the tab Project. For the operation mode, now I select Load ATCOR Project. For the input I select my created project folder. Now you can see that the other options changed and are grayed out. This other information is filled automatically. See for example the sensor, which is correct with Sentinel-2. For the output I select my output folder, select the image and change it to _Addcore2. Second, for the tab Basic Settings. In the sensor information and the geometry box, the metadata values are shown as they were read from the metadata file when the project was created. See here for example the date. I do not have to touch and edit these values. What I do change are the settings in the atmosphere box. I check the water vapor category and select US Standard. Further, for the aerosol type, I select Auto. Hereby, ATCOR will select the most suitable aerosol type automatically. Last but not least, the Advanced Settings tab. For the first option, in the Scaling box, I keep the default for the reflectance scale factor. If unchanged, the reflectance in the output image will be scaled by 100. With ATCOR, I do have different options to get further products. Therefore, in the box Value Added Products, I check Compute Value Added Products. Then I run the Addcore2 process. As before, click on the IDL window to confirm. Now the process runs again for some minutes. The Addcore2 workflow has finished its processing task. I'm curious. Let us have a look at the result. Now you can see the San Francisco scene atmospherically corrected. I will use the swipe tool another time. Now, using the Inquire cursor, I can compare the result of the atmospherically corrected image with the original image. The corrected image provides a surface reflectance spectra. You can easily calculate the surface reflectance in % by dividing the pixel value by 100. This is the applied reflectance scale factor, as previously explained in the Advanced Settings tab. Now I will examine the spectral profiles. Therefore, I select the Golden Gate Park as I think it might be suitable for this purpose. The first profile is for the original uncorrected image. Thus, no dehaze nor atmospherical correction has taken place. I will pick the sports field. For the Spectral Profile tool, always the lowest layer is considered. This is why I moved them in the table of contents. I will compare this with the dehazed and Addcore2 corrected image. The differences for the same spot are obvious. Another time, a look into the project folder. I mentioned already the project file. Do not rename it. However, I want to show you the calibration file in the text editor. It contains the sensor and image-specific calibration parameters. As for Sentinel-2 data, a metadata import is provided. The calibration file will be prepared and written to the project folder. Next, let us examine the log in a text editor. It contains detailed information about the executed process, such as the scene average global flux, reflectances, but also warnings and error messages. Just have a look by yourself. Also pretty important and informative, the image session log. To access it, in Imagine go to File, Session, and open the log via the View Session Log button. It lists the single steps which have taken place or which actually happen live, if you keep this window open during processing. Finally, what I do not want to keep from you is the Value Added Products file. You remember, we checked the options in the Advanced Settings tab. Let's have a look at it. I move to File, go to Open and select Raster as Image Chain. I select from the output the Addcore-2_FLX image file, go to Image Chain and select Pseudocolor. I select the first layer and the NDVI natural in the color table. The first layer is the Soil Adjusted Vegetation Index, abbreviated as SAVI. In this video tutorial, you have learned how to use the ATCOR Imagine workflow to dehaze and atmospherically correct a multispectral Sentinel-2 image. Thank you for watching. I hope this was helpful. For further information, visit our homepage geosystems.de.